Welcome to the deep dive. Today we're heading virtually, of course, to Mars, specifically the rim of Jezero Crater. It sounds like NASA's Perseverance rover has, well, really hit a geological jackpot up there.
Oh, absolutely. A real treasure trove, you could say. They're finding incredibly old, really diverse rocks.
And the key thing I gather is the water connection.
That's right. That's what makes it so compelling for us. So many of these rocks, they show clear signs, clear evidence of interacting with water, like billions of years ago.
So we're not just looking at interesting geology, we're potentially finding clues about Mars's ancient past.
Exactly. How it changed, over these huge timescales. And the really big question, could life, even just microbial life, have existed there once?
Right. Perseverance got up to the rim back in December after a bit of a climb, and it seems like the science has just exploded since then.
The pace has been, well, astonishing, really.
Yeah.
Much faster than down on the crater floor.
It feels like we're finally turning the first few pages of Mars's, I don't know, its autobiography. So, okay, our mission today. Let's dig into why these rocks are so significant, what they're telling us.
And the pace is remarkable. Since getting up there, Perseverance has already drilled core samples from 5 different rocks.
5 already? Wow.
And successfully sealed 3 of those samples, in those airtight tubes for maybe, hopefully, coming back to Earth someday. That's a lot, pretty quickly.
Yeah, that's huge. And it's not just drilling, right? They're doing other analyses, too.
Oh, yeah. Beyond the cores, it's been looking really closely, detailed studies of 7 rocks, and used its laser on, get this, 83 more rocks to check their chemistry.
83. That's a flood of data coming back.
It really is. It just shows how sophisticated and efficient this rover is. And this area, which Hazel Hill, the slope they're on, it seems to be just packed with variety. More than expected, maybe.
It sounds like the science team is almost like spoilt for choice. I saw a quote from Katie Stack Morgan, the project scientist, saying there are new and intriguing rocks everywhere the rover turns. It paints a picture, doesn't it? So give us the quick version. Why is this spot, the rim, so special geologically?
Okay, so the rim, it's basically where different bits of Martian history collide.
Yeah.
It's a really unique place. You find these shattered rocks, right? Once molten, probably from huge meteor impacts from way back.
Like the impact that made Jezero Crater itself?
Possibly. Yeah, potentially that one.
Yeah.
Billions of years ago. Rocks basically blasted out from underground.
Incredible.
But then right next to those, you've got these layered rocks. Rocks that formed, more gradually on the surface over billions of years.
So impact debris and ancient surface layers side by side.
Exactly. And the really fascinating part is that some clearly interacted with lots of water, while others seem to have stayed pretty dry. It's this mix, this juxtaposition, that makes it a scientific goldmine.
Okay, let's get into specifics. The first rim sample, Silver Mountain, that was back in January, from a rock called Shallow Bay. What's the story there?
All right, Shallow Bay. This one's super interesting because our analysis, it suggests it formed way back, like at least 3.9 billion years ago.
Wow, 3.9 billion.
Yeah, that puts it right in the Noachian period. Think of that as like the dawn of Mars time. It's crucial because Mars might have been, well, warmer, wetter back then, maybe a thicker atmosphere.
So this one rock could tell us about conditions way back when Mars might have been, dare I say, habitable.
Potentially, yes. Direct evidence from nearly 4 billion years ago. It's pretty mind-blowing.
Almost 4 billion years. And I read there's a suggestion it had a rough life. Something about being broken up.
Yes, exactly. There's a good chance it was shattered and then recrystallized by a later meteor impact. So you get clues about early Mars and the violent impact history, maybe all in one sample.
Okay, so after Shallow Bay, the team looked at another spot nearby. Something with igneous minerals.
That's right. An outcrop about 360 feet away. Igneous minerals, meaning they crystallize from molten rock, magma, probably from deep inside Mars.
Which sounds like another great find, potentially, like a time capsule of Mars's inner workings.
Definitely. Igneous rocks, their crystals can lock in really precise information about, when and how they formed, a frozen record, basically. But this particular rock, it didn't cooperate.
The crumbly one. Right, I remember reading they tried drilling twice in early February and it just fell apart.
Yeah, essentially too brittle. It just fractured during coring, couldn't hold together to make a solid core sample. It shows the practical challenges. Sometimes the most interesting rocks are the hardest to sample.
So plan B, they didn't give up, I assume.
No, absolutely not. They pivoted, moved about 520 feet northwest to a different spot, nicknamed Tablelands. And this is where the water story gets really interesting again.
Tablelands. This is the one made almost entirely of serpentine minerals, right? Okay, break that down for us non-geologists. What's serpentine, and why is it such a big deal for the life question?
Okay, sure. So serpentine minerals, they form through a process called serpentinization. Big word. But basically, it happens when you get lots of water reacting with specific minerals, iron and magnesium-rich ones, usually in igneous rock.
Water changing the rock.
Fundamentally changing it, yeah.
Right.
Alters the structure, the mineralogy. Often the rock actually expands and cracks. But here's the kicker. This process, serpentinization, can release hydrogen gas.
Hydrogen. Okay.
And if there's carbon dioxide around, that hydrogen can lead to methane. Now think about Earth. Environments where this happens, even deep down, no sunlight, they can support whole microbial communities.
Whoa! So finding serpentine on Mars is like finding a potential ancient habitat.
It's a very strong indicator of conditions that on Earth do support life. So yeah, it's a really significant find.
And they did manage to get a core sample at Tablelands, but then another hurdle, sealing the tube.
That's right, yeah. Seemed like some really fine powdery rock got stuck at the top of the tube, preventing that perfect airtight seal. It had happened once before, but this time it was really stubborn.
13 Martian days souls they worked on it. That's dedication. 33 times brushing the top, 8 sealing attempts. That team doesn't quit. A sol is just slightly longer than an Earth day, for context.
Incredible perseverance from the Perseverance team, you could say. And then they tried something, well, pretty clever, the flick maneuver.
The flick maneuver? What on Mars is that?
Well, basically, they used the robotic arm to carefully press the sample tube against part of the rover, then pulled it away sharply. The idea was to create a little vibration, like flicking it, to jiggle that powder loose.
You're kidding, like tapping a jar lid with a multi-billion-dollar rover arm.
Sort of. It sounds simple, but it's incredibly delicate engineering. And guess what?
It worked.
It worked. The combination of all that brushing and the flicking, they finally got it sealed tight on March 2nd. A real engineering win.
Wow, that's amazing. So Silver Mountain, Tablelands, then a third sealed sample came quickly after.
Yep, just 8 cells later. Much smoother process this time. They cored a rock called Main River.
And Main River sounds visually different, too. Something about bands.
Yeah, reports say it has these unusual alternating bright and dark bands. Apparently quite unlike anything they'd seen before on Mars.
Huh. Makes you wonder what created that pattern. Another geological puzzle piece.
Exactly. Each sample, sealed or not, tells its own unique story. And the exploration there, it's definitely not finished.
No, they're still checking out other spots on Witch Hazel Hill. Names like Sally's Cove, Dennis Pond, Mount Pearl.
That's right. Still analyzing outcrops. The science team clearly thinks there's more to learn right there on that hill. All this data helps them choose where to drill next. It's strategic.
Okay, let's zoom out a bit. Remind us where Perseverance fits in the bigger picture. Mars 2020 mission, part of the whole Moon to Mars thing.
Correct. It landed in Jezero in 2021. And its main goal, its prime directive almost, is astrobiology, searching for signs of ancient microbial life.
By studying the geology, the past climate, figuring out if Mars could have supported life.
Yeah, precisely.
Yeah.
But it's also paving the way for humans, testing technologies, checking out the environment for future astronauts.
And it's the first mission ever designed to actually collect and cache samples, right? To leave them for pickup later.
Yes, that's historic. These samples we've been talking about, Silver Mountain, Tablelands, Main River, plus the unsealed ones that are being stored, cached on the surface.
For the Mars Sample Return Program, the joint effort with ESA.
That's the grand plan. A future mission, or series of missions, aims to go there, collect these sealed tubes, and bring them back to Earth.
Back to labs here where we can hit them with, well, everything we've got analytically. Instruments way beyond what you can fit on a rover.
Exactly. The level of detail we could get would be phenomenal.
It's such a long game, this kind of exploration, but these discoveries on the rim already feel huge. What's the main takeaway for you, for the listener right now?
I think it's the potential. Yeah, these rocks, especially the water-altered ones like at Tablelands, they genuinely hold the potential to, well, rewrite our understanding of early Mars. And maybe, just maybe, the conditions needed for life itself.
So as Perseverance keeps exploring, and we wait maybe years for these samples, the question lingers, doesn't it? What ultimate truths about life's beginnings, perhaps beyond Earth, are locked away in these Martian rocks? It definitely keeps you looking up. Thanks for taking this deep dive with us.